All right, calculus. Welcome to, I'm going to check the volume here. Welcome to, section 5.5, day 2. Probably looking at 4 or 5 videos for section 5.5. It is U substitution. It's very, very important. We use U substitution when we, or integration by parts later, when we can't think of the antiderivative quickly. All right, so like tangent of x. We don't know what the antiderivative of tangent of x is. So what we're going to do, this is number 1 here for you today. Example 5, I guess, of this first part. You can call whatever example you want. All right, I want to integrate tan x dx. I want to find that antiderivative. So what I'm going to do is I'm going to rewrite tangent as sine over cosine. All right, now let's look here. If I have sine over cosine, I got 2 different options. If I let u be sine x dx, then du, you don't write this down, du would be cosine x dx. But there's a problem. Cosine's in the denominator. There is no like 1 over du situation. We don't want that, okay? So a lot of times we're going to let u be the denominator. A lot of times. So let u be cosine x. If I let u be cosine x, then du is negative sine x dx. And look what we have up here. We have sine x dx. So, again, my goal, substitute something in. If that's u, then I need to substitute something in terms of u for that. So sine x dx would be negative du. Again, if I let u be cosine x, then du, the derivative of u, would be negative sine x dx. Negative du would be sine x dx. All right, that would be negative du. That would be u. Everything's good. So here I'm going to put that negative on the outside. Du would be up top, so it's like 1 over u. All right, I can take the antiderivative of that. The antiderivative of 1 over u is natural log of u plus c. We don't have any bounds. And then lastly, I plug in what cosine is. Now this is a fact, so the antiderivative of tangents is natural log. They use absolute value here because remember you can't take natural log of 0 or a negative. In cosine, you know, the cosine can be negative and 0, and so can secant. That's why they use the absolute value for any antiderivative, okay? And really, so what do we got here? Now, you know, I'd probably accept this, but notice what they did here. Why is the antiderivative of tangents natural log of absolute value, secant x plus c? It's something Algebra 2 is doing right now. Remember, number on the outside of a log or a natural log can be written as an exponent. So bring that number up. What's cosinverse, or the, you know, cosine to the negative first would be 1 over cosine. 1 over cosine is secant. So that is the best answer there. That is a fact. The antiderivative of tangents is natural log of secant x plus c. All right, so time to institute some bounds here. I'm going to do it 2 different ways. I think you'll like one way better, and I think I'm going to do that from here on out. Bounds of 1 to e natural log x dx. Now, notice I just said a lot of the time my denominator will be u. Here's the problem though. If I let my denominator be u, then du would just be dx, and I would have nothing to plug in for that. So I'm going to let you, again, you kind of have to play around, do a little guess and check. All right, we're going to do 32 of these in total. I think after that you get the hang. So let u be natural log of x. So if I let this be u, what's nice is that du is 1 over x dx. 1 over x dx. This is what du is. And look at that. Got something to plug in for that. Got something to plug in for that. We're all good. So I can write this as 1 to e. Now, if I wanted to, I could switch the bounds and make this totally in terms of u now. Notice if, and I'm going to do this after this next one, I believe. If I wanted to, I could change the bounds and make this totally in terms of u. If u is natural log x, then my first bound would be natural log 1, which is 0. If u is natural log of x, then my second bound would be 1. So my bounds would change from 1 to e to 0 to 1, but I did not change the bounds in this one. So we're just going to do it this way, and then after that, I think we'll start, pretty soon we'll start changing some bounds. All right? I probably didn't change any bounds in college, though. So what do I got? U is natural log x, and that was up top, the numerator. And then 1 over x dx was du, so it's going to be multiplied by du. Take the antiderivative, 1 power up divided by the new power. 1 power up divided by the new power. Plug in e, plug in 1, but if you didn't change your bounds, you're plugging in e to something with x. That doesn't describe anything with x, so what is u? Remember, u is natural log x, so I got to plug that in right there. Okay, so really what I'm dealing with is 1/2 natural log x squared with bounds 1 to e. That's really what I'm looking at, okay? Put the 1/2 on the outside. I plug e in for x minus, plug 1 in for x. Natural log of 1 is 0. Natural log of e to the first is just 1. So it's 1 squared minus 0. Multiply that by 1/2, and that's how we get 1/2. Okay, now I'll show you how we can just change the bounds right from the get-go. We don't have to worry about resubstituting something in. See, I had to substitute something in for, I had to substitute something with u in for x, then I had to put that x back in with bounds. It's a little too much. Okay, so find that, evaluate that integral. Now, obviously, I can only let u be 3 minus 5x. Okay, so u is going to be 3 minus 5x. That is u. So what's du? du is going to be negative 5 dx. What do I need? I just need dx. And I can make that happen by dividing both sides by negative 5 or multiplying by negative 1/5. So dx, and I want to plug something in for that, and that only, is negative 1/5 du. So negative 1/5 goes on the outside. I have du. All right, 1 over u squared, because u is at the bottom, which is going to be this. All right. Uh-oh. Hear Elsie on the baby monitor there. She's only halfway through her nap, though. She's got to keep going. Does this every day. All right. Like a 7th inning cry stretch. All right. So what we're going to do is we're going to take the antiderivative of u to the negative second. It's going to be 1 power up divided by the new power. Right there. That's how it turns out to be. Now, again, this was only in terms of x, so I got to substitute what u is. What is u? Now, notice a negative times a negative is a positive. That's how I got a 5th. All right, a 5th of 1 over u. It's right there. That's a u. What is u? 3 minus 5x. Now I evaluate. Oh, my gosh. Okay, so I plug 2 in. I'm going to get 1 over negative 7 minus, plug 1 in. I get 1 over negative 2. And if I make a boo-boo anywhere, please let me know. Little arithmetic can be the same denominator. And then multiply, I get 1/14. All right, my goal in this video is to do one more page with you. The next 3 have no bounds, so those shouldn't be too bad. And that'll be the end of day 2. All right, we're going to evaluate this. No bounds. So let's look here. Same one. All right. So I'm going to let u be 4 plus x squared. Again, if I let u be x, then du is dx, and this is, I got to plug something in for that. I would have nothing. So if I let u be this, then I would have u to the 10th. And what is du? Du then would be 2x dx. I would then just need to plug something in for x dx, and I've almost got it. I just divide both sides by 2. So 1/2 du is x dx. All right, now I have something to plug in for that, and I have something to plug in for this. Check, that's the whole goal. So I'm going to have a 1/2 on the outside, and what was I doing to u? Remember, u was 4 plus x squared. I was raising u to the 10th power. All right. Just take the antiderivative of u to the 10th, 1 power up, right here, divided by the new power. All right, so that is going plus c. It's going to be u to the 11th divided by 22, but what was u? U is 4 plus x squared. Raise it to the 11th divided by 22, plus c. All right, got 2 more for this second video for section 5.5. Again, we're going to do a lot of these. Everyone that's really in your the homework exercise section of 5.5 in the 5th and 7th edition of this book, it will get a little bit easier. This is essential if you're going to progress with Calculus 2 or going to take Calculus 1 again next year. Which, folks, with this abbreviated schedule, this chaos, if you have Calculus 2 in your future, we're going to highly recommend that everyone take Calc 1 again next year. Start off with some confidence. This is not the way we want to end. All right? So, what do we got here? Kind of makes sense to let u be the square root of x. All right? If I let u be the square root of x, which is x to the 1/2, the derivative of u would be 1 over 2, because again, it'd be 1/2 x to the negative first. We should be able to do that quick. It'd be 1 over 2 times the square root of x. What do I want to plug in? I want to have something to plug in for 1 over the square root of x dx. dx in the numerator, square root of x only in the denominator. I almost have that. I just need to get rid of that 2. How do I get rid of that 2? We've been dividing a lot. In this case, you would actually multiply by 2. 2 du would be 1 over root x dx. Remember, this is going to be u. It's going to be sine u. It's going to be 2 on the outside du. And that's how it's going to be written. What is the antiderivative of sine u? It's negative cosine u plus c. What is u? Square root of x. All right, some of these you can guess by doing antiderivative. Some of them aren't too bad. Like 10, you could probably guess what it would be, the antiderivative of this. Sometimes it's easy to do that with e. Anytime, really, I have e to some power, that power is probably going to be what u is. U, I'm going to let that be sine theta, because the derivative of sine theta is cosine theta d theta. It's exactly that. It's exactly that. So this really couldn't be easier. E to the u du. E to the u plus c. Again, folks, the antiderivative is if you take the derivative of this, you will get that. So some of you might know that automatically if you're good with the antiderivatives, and good for you. All right, folks, I'm going to have, I think, 3 more videos because we've just done 10. We've got 22 more to go. Pause this, take your time, write these notes out again a second or third time. You have the time. I know it seems redundant, but that is how you're going to learn. Well, my wife did that in high school, and she got a full ride scholarship because of those great note-taking skills. All right, this is Yak Math Videos signing out.